Hello, this is the second video of the first sequence and series section on summing series for OCR Pure Core Further Mathematics. In this session we will introduce the standard formula for the sum to n terms of R. In the previous video we looked at using the sigma notation, so here we know that we are summing the terms R from R equals 1 to n, and that this would look like 1 plus 2 plus 3 plus going on up to n minus 1 plus n. If we remember what an arithmetic series looks like, A plus D, A plus 2D, and so on, then we could see that this is like summing an arithmetic series where, in this case, A is 1 and D is also 1. Hence we can use the standard result for summing an arithmetic sequence, leading to the Sn equals n times n plus 1 over 2. You may have already covered this in your A-level maths or even at GCSE. Let's have a look at a really quick example as to why this would work. Gauss came up with this as a young boy in a schoolroom when he wanted to avoid the tedious task of summing between 1 and 100. For us, let's just have a look at summing between 1 and 5 for R. That would give us 1 plus 2 plus 3 plus 4 plus 5. If we were to write that backwards, in other words 5, 4, 3, 2, 1, and then add those columns, we would have 1 and 5 would give us 6, 2 and 4, and so on. And that would give us 5 lots of 6. But of course, we have twice as much as we actually want there. Therefore, if we just want S5, we can see that we would just have to half the 5 times 6. When we generalise this, you can see that's where we get the Sn equals n times n plus 1 over 2 from. Another way of regarding this is to think of the triangle numbers. As you can see, you would have, if you just had the first term 1, it doesn't look very triangular, but when you look at the 3 and then you add another layer to get your 6, and then the next layer where you're balancing, if you think of it as sort of little balls on top of each other or building up, then you can see why they're called triangle numbers. So what happens when we start adding the triangle numbers? Here you can see that we've added 2 lots of the triangle number 15. And that it gives us a rectangle 5 by 6. Which, if we generalised again, would give us 2 triangle numbers of n components, would give us n times n plus 1, leading to the same result. But just showing it to you via a diagram. So if we're using this formula for r equals 1 to 100, we simply know that we're going to have a half times 100 times 101. Or in other words, 10100 over d, which has saved us a lot of tedious adding up. If we have a look at this example here, remembering we can take the 3 out and then we can use the standard result. So that would be 3 lots, and we're going from 1 to 16, so we're going to have a half times 16 times n plus 1, which would be 17, which gives us, we can use our calculator, but it still saves time from adding up all those terms, 408. In the next video, we'll go on to look at the standard formula for the sum to n terms of r squared and r cubed.